Hello students, myself Amrita Dhar, Assistant Professor of Electrical Engineering Department of Greater Kolkata College of Engineering and Management, JIS Group. I will teach you Power System 1.
Now the syllabus of the Power System 1 has been almost covered, but I have missed some topics. In this video I will discuss about those topics. Indian Electricity Rule 1956, General Introduction from Module 1, Influence of Earth on Conductor Capacitance from Module 2, Dielectric Loss and Loss Angle from Module 3, Power Circle Diagrams from Module 5, and Guidelines for Tariff from Module 6. So first start with Indian Electricity Rule 1956 from Module 1. What is Indian Electricity Rule? The Indian Electricity Rules 1956 was made under Section 37 of the Indian Electricity Act 1910. Now redefined after an enactment of the Electricity Act 2003. Next, who is the governing body of Indian Electricity Rule? SEER, namely Central Electricity Authority Regulations. Central Electricity Authority measures relating to safety and electric supply. 2010 came into effect from 20th September 2010 in place of the Indian Electricity Rules 1956. These rules themselves were being allowed to be enforced till rules under Section 53 of the new Act are. Now, IE rules mainly dealt with appointment of inspectors and their duties, licensing provisions, general safety requirements, conditions relating to supply and use of energy, electric supply lines and systems for LV and MV, electric supply lines and systems for HV and EHV, overhead lines and underground cables and generating stations, electric traction, precautions in the mines and oil fields. Now safety requirements under Indian Electricity Rules. Under Section 36 of Indian Electricity Act 1910, a board called the Central Electricity Board is constituted, and under Section 37 of the Act, the board is invested with power to make rules for the whole or any part of the territories to which this Act extends to regulate the generation, transmission, supply and use energy, and generally to carry out the purposes of the object of this Act. The Indian Electricity Rules are expected to serve the interests of project administrators, licensees, electrical engineers, work managers, licensed contractors, electrician, wiremen, and indeed all those who have to deal with generation, transmission, conversion, distribution, supply and use of electrical energy, including customers. Each one has a role to play in the safe use of electricity. Every rule in the Indian Electricity Rules 1956 is related either directly or indirectly to safety. Some of those that have a direct relevance to safety have been selected and listed below for reference. Safety rules. Among safety rules, the following are important and indeed particular attention. Rule 32. Switches shall be on the live conductor. No cutout, link or switch other than gang switch shall be inserted in the neutral conductor. Code of practice of wiring shall be followed while marking the conductors. Rule 50. Energy shall not be supplied, transferred, converted or used unless the following provisions are observed. A suitable linked switch or circuit breaker is erected at the secondary side of the transformer. Every circuit is protected by a suitable cutout. Supply to each motor or group of motors is controlled by a linked switch or circuit breaker. Adequate precautions are taken to ensure that no live parts are exposed. Now special provisions in respect of high and extra high voltage installation. Rule 63. Approval of inspector is necessary before energizing any high voltage installation. Rule 64. All apparatus and equipment intended to be used at high or extra high voltage shall be inaccessible except to an authorized person. A suitable segregation shall be provided for licensee's equipment. A suitable soak pit or arrangement to drain out the oil shall be made in substations where the transformers are provided. Cable trains shall be fitted with sand or other inflammable material and covered by the brick. The installation must be subjected to the prescribed testing before the energizing. Rule 66. Conductors shall be enclosed in a metallic covering and suitable circuit breakers shall be provided to protect the equipment from overloading. Rule 68. In case of outdoor type of substation, a metallic fencing of not less than 1.8 meter height shall be erected around the transformer. Provisions in terms of overhead line. Rule 79. Clearance of low and medium voltage lines from building. Vertical clearance is 2.5 meter and horizontal clearance is 1.2 meter. Rule 80. Clearance from building of high and extra high voltage. Vertical clearance high voltage up to 33 kV 3.7 meter. Extra high voltage above 33 kV 3.7 plus 0.3 for every 33 kV part thereof. Rule 80. Clearance from building of high and extra high voltage pitched roof. Vertical clearance up to 11 kV 1.2 meter, up above 11 kV and up to 33 kV 2.2 meter, above 33 kV 2 meter plus 0.3 meter for every 33 kV part thereof. It shall not exceed Rule 85. Maximum interval between supports. It shall not exceed 65 meter except by prior approval of inspector. Next is the dielectric loss. Dielectric loss quantifies a dielectric material's inherent dissipation of electromagnetic energy. Example, heat. It can be parameterized in terms of loss angle delta or the corresponding loss tangent tan delta. Both refer to the phasor in complex plane whose real and imaginary parts are the resistivity component of an electromagnetic field and its reactive counterpart. Dielectric loss angle. The phase difference between the electrical field vector and the electrical displacement in a dielectric material is the dielectric loss angle, and this phase difference is caused by energy losses in the dielectric. Loss tangent. The tan delta D is equal to 1 by Q is the dissipation factor and Q is a quality factor. And tan delta is equal to energy lost per cycle by energy stored per cycle. Tan delta is equal to epsilon r double dash by epsilon r dash, energy lost per cycle, energy stored per cycle. Next is power circle diagram. Now we determine the power circle diagram for sending end power and receiving end power. Sending end power circle diagram. Now you all know these equations. Sending end power voltage is equal to AVR plus BIR, where VR is the receiving end voltage and IR is the receiving end current. And IS, which is sending end current, is equal to CVR plus DIR. Now from this equation we determine the value of IR. IR is equals to VS by B minus A by B into VR. Now in this equation put the value of IR. We put the value of IR in place of this. Now on solving this we get CVR plus DVS by B plus minus DA by B into VR. Now I take common VR. So it becomes D by B Vs plus VR into C minus AD by B. We all know the AD minus BC is equals to 1. So BC minus AD is equals to minus 1. So the equation becomes D by B Vs minus VR by B. This is our first equation 1 and this is our second equation. Now sending end apparent power is equal to Vs Is conjugate. Now solving this Vs square, D is equals to A, so we put in place of D A by B, angle beta minus alpha, because the angle of A is alpha and as there is a conjugate, so we put minus alpha and this is minus beta, but here is a conjugate, so this is become plus. So beta minus alpha is the angle, minus Vs into Vr by B, here angle is delta, angle of voltage is delta plus beta. So this phase angle is beta minus alpha and this phase angle is delta plus beta. Now PS is equal to A by B Vs square cos beta minus alpha minus Vs Vr beta cos delta plus beta, and QS, that is reactive power, is equal to A by B Vs square sin term sin beta minus alpha minus Vs Vr by B sin delta plus beta. Now this is the radius of the circle and this is the center of the circle. Now we draw the sending end power circle diagram. So the this is the center. What is the value of center? A Vs square by B, or we can write in place of A D Vs square by B. So we write D Vs square by B. This is the center. And what is this? Now we take a third quadrant over here. We take third quadrant and this angle is beta plus delta, and if this is delta, then this angle is beta, and we take this is our reference line. And what is the value of radius? Now we draw a circle and center is this, the center is CS. We draw a circle whose radius is Vs Vr by B, Vs Vr by B. So this radius is equal to Vs Vr by B. And now this is the circle and we draw a line from center to over the circle, and this is our SS, and this y-axis is QS because we are taking y-axis as reactive power axis and x-axis as active power axis. So this is the value of active power and this is the value of reactive power. Next is receiving end power circle diagram. Receiving end, so we again write the value of Vs and from here we get the value of IR is equal to Vs by B minus A by B into VR. Now SR is equals to VR into IR conjugate, so we put the value of IR and then we solve this VR Vs by B beta minus delta. Now this is for the conjugate, and minus AVR square by B angle beta minus alpha. This actual the angle is alpha minus beta, but as there is a conjugate, so the angle becomes beta minus alpha. Now PR is equals to Vs Vr by B cos of beta minus delta and AVR square B cos of beta minus alpha. And what is QR? Reactive power, Vs Vr by B sin beta minus delta, AVR square by B sin beta minus alpha. Now this is our equation 2 and this is our equation 3, and equation 2 square plus equation 3 square is equals to PR plus AVR by B cos beta minus delta the whole square plus QR plus AVR square by B cos sin beta minus alpha whole square is equals to Vs Vr by B whole square, because cos square beta minus delta plus sin square beta minus delta is equals to 1. The center is A Va square B cos beta minus alpha comma A Vr square B sin beta minus alpha, and the radius is Vs Vr by B. Now we draw the receiving end power circle diagram. Now this is our origin and this is the center. The center is A V square B cos beta minus alpha and A V R square B sin beta minus delta. So this located in the third quadrant, and this located in the third quadrant, and this is equal to A by B VR square cos beta minus alpha, and this is equal to A by B VR square sin beta minus alpha. Okay, now now making center at this point, draw a circle whose radius is Vs Vr by B. So we get the receiving end power circle diagram. Now this is the value of active power and this is the value of reactive power. Effect of arc on capacitance of transmission line. So far, now in calculating the effect of arc on capacitance of transmission line, the presence of arc was ignored in our previous derivations. The effect of arc on capacitance of transmission line can be conveniently taken into account by method of images. The electric field of a transmission line conductor must conform to the presence of the earth below. The earth for this purpose may be assumed to be a perfectly conducting horizontal sheet of infinite extent, which therefore acts like an equipotential surface. The electric field of two long parallel conductor charged plus q and minus q per unit in such that it has a zero potential plane midway between the conductors, as you can see in this picture, plus q and minus q per unit charged are placed in such a way that it has zero potential plane midway between the conductors, zero potential plane. Now if a conducting sheet of infinite dimension is placed at the zero potential plane, the electric field remains undisturbed. Further, if the conductor carrying plus minus q is now removed, the electric field above the conducting sheet stays intact, while that below it vanishes. Okay, now using this well known result in reverse, we may equivalently replace the presence of a ground below a charged conductor by a fictitious conductor having equal and opposite charge and located as far below the surface of the ground as the overhead conductor above it. Such fictitious conductor is the mirror image of the overhead conductor. This method of creating the same electric field as the presence of earth is known as method of images, originally suggested by Lord Kelvin. Next, capacitance of a single phase line. Now it is required to calculate its capacitance of transmission line taking the presence of earth into account by method of images. Just I have described the equation for the voltage drop VAB as determined by the two charged conductor A and B and their images A dash and B dash can be written as VAB is equal to 1 by 2 pi K QA ln D by R plus QB ln R by D plus QA dash ln 4 root over 4h square plus d square by 2h plus QB dash ln 2h root over 4h square plus d square. Now QA, QB are the charges and QA dash and QB dash are the mirror image. Now VAB is equal to Q by pi K ln 2HD R 4h square plus d root over 4h square plus d square. Now what is H? H is the distance from ground to minus Q charge, and also the distance between ground and plus Q charge is H. So this distance, the distance between mirror image of the charged A dash charge B is root over 4h square plus d square. Similarly, this distance is also root over 4h square plus d square. D square is the distance between conductor A and conductor B. Now CAB is equal to pi k by ln d r 1 plus root over d square by 4h square Faraday per meter line to line. And you all know what is the neutral capacitance? Twice the capacitance between line. So it is observed from the above equation that the presence of r modifies the radius r to r into 1 plus root over d square by 4h square. For h large compared to d, the effect of r on line capacitance is of negligible order. This is the normal case where h is larger compared to d. Next is the capacitance of a three-phase line. The method of images can similarly be applied for calculation of capacitance of transmission line of a three-phase line. You can see this picture. The line is considered to be fully transposed. The conductor ABC carry the charges QA, QB and QC and occupy positions 1, 2 and 3 respectively in the first section of the transposition cycle. The effect of earth is simulated by image conductor with charges minus QA, minus QB and minus QC respectively. The equations for the three sections of the transposition cycle can be written for the voltage drop VAB as determined by the three charge conductors and their images with conductor A in position 1, B in position 2 and C in position 3. VAB is equals to 2 pi k QA in the first bracket ln D12 by R, ln D12 by R minus ln H12 by H1 minus ln H12 by H1 plus QB ln R by D12 minus ln H2 by H12 plus QC ln D23 by D31 minus ln H23 by H31. Or VAB can be written for the second and third section of the transposition cycle if the fairly accurate assumption of constant charge per unit length of the conductor throughout the transmission line is made. The average value of VAB for the three section of the cycle is given by this equation. VAB is equal to 1 by 2 pi k QA ln D equivalent by R minus ln H12 H23 H31 whole to the power 1 by 3 by H1 H2 H3 whole to the power 1 by 3 plus QB into ln R by D equivalent minus ln H1 H2 H3 whole to the power 1 by 3 by H1 to H23 H31 whole to the power 1 by 3. The equation for the average value of phasor VAC is found in a similar manner. Proceeding the lines of section using VAB plus VAC equal to 3 VAN and QA plus QB plus QC equal to 0, that's for balanced condition, we ultimately obtain the expression for capacitance and neutral capacitance. 2 pi Cn is equal to 2 pi n ln D equivalent by R minus ln H1 to H23 H31 whole to the power 1 by 3 H1 H2 H3 whole to the power 1 by 3. C neutral capacitance is equal to 0.0242
Pi log
D equivalent by R minus log H1 to H23 H31 whole to the power 1 by 3 by H1 H2 H3 whole to the power 1 by 3 microfarad per kilometer to neutral. Now it is evident that the effect of earth is to increase the capacitance of a line. If the conductors are high above the earth compared to the distance among them, that means if H is higher than capital D, the effect of earth on the capacitance of three-phase lines can be neglected. Types of tariff regulation. Tariff regulation is divided into conventional energy sources, renewable energy sources. Then conventional energy sources is divided into generation and transmission. Conventional energy source. Tariff determination and computational of capital cost and capital structure. Tariff may be determined for whole the facility or part of it. Generation, whole generating station or stage or unit or block, and for transmission, whole of the transmission system or transmission line or substation. Tariff to be determined within 6 months from the date of application. Commission shall carry out truing up exercise along with the tariff petition filed for the next tariff period. Capital cost shall comprise of loan 70% of the total fund, equity 30% of the total fund. Funds excess of 30% equity will be treated as normative loan, and funds less than of 30% of the equity to be treated as actual equity. For hydro project, cost shall be include R&R cost and 10% contribution towards RGGVY. Next, initial spares shall be capitalized as a percentage of original projected project cost as specified in regulation. Additional capitalization allowed for following the after date of commercial operation and up to the cut-off date may be admitted by the Commission. Undischarged liabilities, works deferred for execution, liabilities to meet award or arbitration, change in law, procurement of initial capital spares, renovation and modernization cost can be accounted on approval by the Commission. Sale of informed power shall be accounted as UI, and after accounting for the fuel expenses shall be applied for reduction in capital cost. Now, computation of tariff is divided into thermal and hydro generating station, capacity charge plus energy charge, and for transmission charges shall comprises of transmission charge for the recovery of annual fixed components. Annual fixed components, return of equity, pre-tax basis at the base rate of 15.5% and additional 0.5% shall be allowed if project completed within the timeline specified. Interest of loan capital, depreciation include salvage value of asset shall be considered as 10%, and second, depreciation shall be allowed up to maximum of 90% of SLM. Next, interest on working capital. Next, operation and maintenance expenses. This include as specified commission in the tariff order. Expense on secondary fuel, oil consumption for coal-based and ignite fire generating station. Interest on capital cost for coal or lignite station generating station, cost of coal or lignite and limestone for 1.5 months for pithead and 2 months for non-pithead. Cost of secondary fuel oil for 2 months. Maintenance spares at 20%. Receivables equivalent of for 2 months. O&M expenses for 1 month. For open cycle gas turbine or combined cycle thermal generating station, fuel cost for 1 month, liquid fuel stock for half month, maintenance spares at 30%, receivable equivalent for 2 months, O&M expenses for 1 month. Next, for hydro generating station, maintenance spares at the rate of 15%, receivables equivalent for 2 months, O&M expenses for 1 month. Useful life. Now, coal or lignite based thermal generating station for 25 years is the useful life. For gas or liquid fuel based thermal generating station, its useful life is 25 years. For AC and DC substation, it's 25 years. For gas insulated substation, it also 25 years. For hydro generating station, including pump storage hydro generating station, 35 years. Transmission line including high voltage AC or high voltage DC, the useful life is 35 years, and communication system is 15 years. Tariff regulation 2014 to 19. Changes in tariff regulation 2014 to 19. Definition of plant load factor and its calculation formula. Definition of date of commercial operation. Definition of trial run and trial operation. For existing transmission project tariff of such project shall be applicable from the date of grant of transmission license, where only a part of generating capacity of generating station is tied up. Tariff of generating station shall be determined with the reference to the capital cost of the entire project. Tariff so determined shall be applicable corresponding to the capacity contracted for the supply of the beneficiaries. Changes in the applications for determination of tariff. Changes in truing up. Controlled parameters are the station heat rate, secondary oil consumption, auxiliary energy consumption, and refinancing loan. Uncontrolled parameters are force majeure, change in law, primary fuel cost, sharing of financial gains along with the sharing formula in the ratio of 60:40. Cost of capital for thermal generating station on the account of PAT, that is performed, achieve and trade, to be considered on case to case basis, defining various exclusion from the capital cost. Now, definition of interest during construction and incidental expenditure during construction. Special allowance for coal-based or lignite-fired thermal generating station on renovation and modernization. Introduction of compensation allowance for the new assets of capital expenditure. In debt equity ratio, any grant obtained for the execution of the project shall not be considered as a part of capital structure. Energy charge shall be derived on the basis of landed fuel cost plus cost of secondary oil consumption. Next, return on equity, base rate of 15.5% for thermal generating station and transmission system and run of river hydro station, and 16.5% for storage hydro station. Additional ROE of 0.5% may be allowed if any element of the transmission project is completed within the specified time limit. 1% reduction in ROE if facility is found to be under commercial operation without commissioning of any RGMO or FGMO data elementary communication system. Additional ROE shall not be admissible for transmission line having length of less than 50 kilometers. Now, change in initial spares for coal and lignite fired thermal generating station for the period 2009 to 14 it is about 2.5%, and for 2014 to 19 it is 4%. For gas turbine or combined cycle it is 4% for the period 2009 to 14, and it is similar in the year 2014 in the period of 2014 to 19. For hydro generating station including pump storage hydro generating station it is 1.5% for the period 2009 to 14 and 4% for the period 2014 to 2019. Transmission line 0.75% for 2009 to 14 and 1% for 2014 to 19. Transmission substation 2.5% for the period of 2009 to 14. Transmission substation greenfield is 4% for 2014 to 19. For brownfield it is 6%. Series compensation device and HVDC station it is 3.5% for the period 9 to 14 and 4% for the period 2014 to 19. For gas insulated substation it is 5% for the period 14 to 19 and 3.5% for the communication system for the period 2014 to 19. Guidelines for renewable energy sources. Tariff structures are return on equity, interest on capital, depreciation, interest on working capital, operation and maintenance expenses. Tariff design. Levelized tariff, it is to be calculated by carrying out levelization for useful considering the discount factor for time value of money. Discount factor, what is discount factor? The discount factor considered for this purpose is equal to the post-tax weighted average cost of the capital on the basis of normative debt equity ratio 70:30. 10.81% for the current control period. Capital cost, debt equity ratio, return on equity 20% per annum for the first 10 years and 24% per annum from 11th year onwards. Interest on loan, average SBI base rate prevalent during the first 6 months of previous year plus 300 basis points. Depreciation 5.83% for first 12 years for loan period. Remaining depreciation shall be spread over the remaining useful life of the project from 13th year onwards. Interest on capital, working capital, average SBI base rate prevalent during first 6 months of previous year plus 350 basis points. Capacity utilization factor, plant load factor, auxiliary power consumption, station heat rate, fuel subsidy or incentive by central or state government. Interest on working capital components, wind or SHP or SPV or solar thermal, operation and maintenance expenses for 1 month, receivable equivalent to 2 months of energy charge for sale of electricity, maintenance spares at 15%. Biomass ranking cycle technology, biomass gasifier, biomass power and non-fossil fuel cogeneration. The regulations are fuel cost for 4 months equivalent to normative PLF, operation and maintenance expenses for 1 month, receivable equivalent to 2 months of fixed and variable charges for scale of electricity calculated on the target PLF, maintenance spare at 15% of the operation and maintenance expenses.
That's all from today's class. If you have any problem, please contact with me. My contact details is given on the first slide. Thank you.